Today, I am quite excited to tell you about how to turn rough ideas into computation with Wolfram Notebook Assistant. And I would say that Notebook Assistant is like a custom version of ChatGPT that has access to all of our documentation and all of the data that makes, say, Wolfram Alpha so powerful. It knows, all of the functions in Wolfram language, knows about all the tutorials, all the examples, and like I said, it has access to all the data that powers Wolfram Alpha. It can improve your code. It can explain code that you got from somebody else. And as is the primary focus of this talk here, it can turn your rough ideas into computation. So Notebook Assistant works like a hyper smart, fully knowledgeable helper that lives right next to or inside of. You can open chat cells in a notebook just by typing an apostrophe. It just lives next to your notebook or inside your notebook. Let me show you some examples. We'll start kind of simple. Say I'm brand new to Wolfram language and I want to know how to do kind of a basic programming task. Let's say, how could I find the running maximum of a list? And then I can just press enter. And this gives us a nice little answer here. So in Wolfram language, we can use the fold list function. And here's an example of how this would work if we had some sort of list. And here, note that the function here is linked. So if I click this has actually opened up the documentation page so I can read all about this particular function that the assistant has linked. So here it gives us an example of this running. And then it also notes, and I think this is kind of a neat thing, that this has access to this through our documentation, that you can use this resource function that kind of automatically does the task that we've asked it to do. Now, Notebook Assistant gives us this answer and it gives us this code. And something that's quite useful is you'll notice that not only can we copy the code, we can insert and evaluate the code here. So if we click this, we get this, and we can see that indeed for this example list that it has come up with, at first, the largest element is 3, starts at 3, and then it stays at 3, and then 5, 7. And then once it hits 8, we stay at 8 because 8 is the largest entry. 7 isn't larger, 5 isn't larger. Once we hit 9, we stay at 9 because 9 is the largest entry. And there we go. Maybe we have an image in our notebook. So let's say we've got some cats. We'll just call it that. But now that I've got this cats here, I could say something like, how could I find where the cats are in the image cats? So here, it asks us to do this, and it tells us this is this function that could be used for this. This is not something I was aware of. This is a new one. And so we go in here, it's giving us coordinates for where the cats are located in the image. There are a couple of different ways you could go about that. And I'm going to ask and see if it's willing to suggest to us a different way, maybe. I ask, is there any other function that could do that? And it knows that I'm referring to this previous chat here and what we have in the notebook. So the Notebook Assistant is aware of the whole chat history above it, and it's aware of everything that's in the notebook over here that it's focusing on. And how can you choose which notebook to focus on? Right here, if you just click this, you can choose any notebook you have open, and you can also just have it choose automatically, which is the default. And what that will do is it will just focus on whichever the last notebook is that you've clicked on. Yeah, so you could use image contents perhaps. And then here we get a nice little data set where it says, okay, we've looked in the image of that I've called cats here. There's nothing special about calling it cats. It's just what I've called it. And we're able to see, oh, okay, there's a domestic cat, and this is the little thumbnail, and another domestic cat, and this is the little thumbnail. And here are the rectangles that are the bounding boxes for these cats. And here are the confidences that this thing has, that this thing is a domestic cat in each case. So that's pretty nice, if you ask me. You can also ask, how could I make a 3D plot of the terrain around a mountain? Okay, so it's letting us know about these functions, but let's see if this did work. So let's just insert and evaluate this here. And that works, no question. So here we can see that we have used the geo-elevation data function here to get Mount Everest as kind of our center point, and then we're kind of looking at a 4-kilometer block around this. That's going to be our data. And then here, it has put that data into a list plot 3D. This is a function you can use to plot a list, which is a Wolfram language generalization of an array. And here it just plugs it in, and it even cleverly, I do think this is actually quite clever, is it uses the mesh functions option and then specifies, this is kind of a pure function notation. It's like a lambda function if you're familiar with that. But what this mesh function does is it's getting the third coordinate. That is, we think about the x, y, and z coordinates in a sense. It's getting the third coordinate and it's drawing nice mesh lines on there. And it's doing that because contextually it's aware that if you kind of want to look at elevation data, you often want to have these lines that indicate how high up you are, these lines of constant elevation. And that can give you a sense of how rapidly the topography is changing. So here we see it's very steep. We see a bunch of lines gathered together, whereas here the topography isn't changing too much. The elevation is pretty constant, so we don't see too many contours there in a sense. And now, because the Notebook Assistant is aware of the previous conversation and of what's in the notebook, I can say things like, so let's say, oh, that's great. Could you make it so the color of the plot depends on the height? Okay, so it gives us some new code here. And if we just insert and evaluate this, we get indeed exactly what we wanted. We can see that we've got a rainbow color scheme here that was just kind of the default that was picked for this. You can ask for other color schemes if you know about them, or if you kind of want to just get roughly close to like an idea of a color scheme you have. But there we go. We're able to pull in this geographic information through the geo-elevation data function. And we're able to pull in all this surrounding information about, what is Mount Everest? Where does it exist exactly? What are its geo coordinates? All that stuff just happens transparently in Wolfram language. And then it's even easier here because you don't even have to have known about this stuff. You can then just ask Notebook Assistant, and not only does it do it for you, but because it provides the code, you can look and you can start to get a sense of like, oh, this is pretty neat. I bet if I put in, another mountain here, let's say, then I could run this again. And here it is for K2, different mountain. So that's just kind of a little example of being able to write code that pulls in functions that use real curated data that we have access to through Wolfram language.